Hello students, welcome to our machine learning lecture series, lecture number 7. Today also we are going to discuss one of the most important topic as part of our machine learning lecture series. Before starting the topic, I would like to request you all who are watching my video, watch the video till end, and if you like my video, then please like, share and subscribe to my channel Visionary Tech. Let's begin into the topic. Decision tree. This is one of the most important supervised machine learning algorithm in machine learning. Okay, let's deep dive into decision tree in detail. Decision tree definition. It is a visual tool used to make decisions or predictions by breaking down a problem into a series of steps based on conditions. Means a big mathematical problem or a big physics based problem or chemistry based problem or any subject based problem, you try to solve. Majorly many professors while explaining, they solve with the help of steps. This means they provide solution in stepwise manner. In the same way here also, it breaks a big problem into series of steps. Step 1, step 2, step 3, like that, based on the conditions. Okay, a decision tree is a visual tool used to make decisions or predictions by breaking down the problem into series of steps. Means breaking down of a big problem into various steps like step 1, step 2, step 3, etc. based on conditions. It starts with root node. Means root node means the main node. The main question arises from the root node and splits into branches. Means possible choices or outcomes from that question. What the extension of the question. It is also called as extension of question. Okay, each leading to more questions or final decision. Final decision is called leaves. Okay, here root node is the main question or main problem, splitted into branches like parts of problem or possible choices or outcomes lead to more questions or final decision. Final decision means what here? Leaves. It is flowchart, helps in making choices and answering simple questions, yes or no based questions at each step. This is about decision tree. So next, decision tree example. Example, it is raining. If yes, take an umbrella. No, go outside without an umbrella. In machine learning, decision tree used to classify data based on features or predict values. Okay. In machine learning, decision tree are used to classify data based on features or to predict values. Okay. This is about example of decision tree. Okay, this is the visualization of decision tree. Please thoroughly look at it. Here it is a decision node. Actually, it is the root node. It is the origin of decision tree. Okay, it is splitted into sub nodes, means parent nodes. Okay, here again it is split into sub nodes. Here this is a parent node. This is a parent node. These both are. This is a child node, and this is again a parent node. This is a parent node, this is a child, this both are child nodes. Leaf nodes are child nodes, decision nodes are parent nodes. Root node is the tree where it's originated, ancestor node, predecessor of the parent node. This root node is a predecessor of this parent node, and this decision node is successful of this successor of this leaf node, and these both are leaf node, means final outcomes. Okay, for example, I will explain again. This is a root node where the problem originated. Okay, this is the parent node, means sub nodes. Okay, this is the process of breaking a problem into sub nodes, into parts, breaking down into parts. We discussed as per definition. This is the child node. This is the outcome. This is again a question. This is again a part of question. Okay, this is the outcome of the questions. So this is about decision tree. So it contains root node, subnodes, leaf node. Leaf node means what? It is a final outcome. Here decision node is the root node where the problem originated, where subnodes called parent nodes which represents branch rules. Okay, here leaf node, it represents outcome of the problem. Okay, next. Next, assumptions of decision tree. This is the most important concept. Okay, decision tree assumes that the things look like don't affect each other. That the things look like don't affect each other. For example, temperature and rain are the examples I took. So here it is clear. Decision tree assumes that things look like do not affect each other. Example, if you are deciding whether to play outside based on is it raining and the temperature above 20 degrees, the tree assumes that just because it is raining it doesn't automatically mean the temperature is low. Okay, it treats these as a separate piece of information. Here even though if it is raining it doesn't automatically mean the temperature is low. It treats both rain and temperature as separate piece of information only. Okay, next, only one question at a time means here a decision tree only asks one question at a time, not a combination of questions. Means the tree first asks whether it is raining. If no, if we give the answer as no, then asks another question, is the temperature above 20 degrees. It doesn't ask something like is it raining, and like it doesn't combine the questions. It asks only one question at a time, and if based on our answer it asks another question or conclude the session. This is about only one question at a time. Next, past data represents future data. Here, the decision tree assumes the patterns from the past will stay the same in the future. This assumption is will be wrong in some cases, will be right in some cases. We will discuss it in later sessions. Okay, this decision tree assumes that patterns from the past will stay the same in future. If we will take some real life situation, this assumption might not be true in all the cases. It is true in some cases, it is true, it is false in some other cases. Okay, if in the past people didn't play outside when it is raining, the tree assumes that in the future people will avoid playing outside in the rains, which might not be true in future. We can't predict it. Okay, this is about past data represents future data. Means once again I will explain. The decision tree assumes the patterns of the past data will stay the same in the future. Means here if in the past people doesn't play outside when it is raining, then the tree assumes the same, that even in the future also people still avoid playing outside when it rains. Okay, this is about assumption of decision tree. Next, decision trees are like flowcharts. Advantages, this is about advantages of decision tree, sorry. Okay, decision trees are like flowcharts, making it simple to see how decisions are made. Okay, it is easy to understand and interpret. Example, you can easily explain a decision like play outside if it is not raining and temperature is about 20 degrees. Okay, next, handles both numerical and categorical data. This is most important advantage. Decision tree can work with numbers and as well as categories. Example, is it raining, yes or no. Okay, this is categorical. Yeah, even it works with numerical also in the same way. Example, you can use a decision tree to decide whether to buy a car based on a price, means that is numerical, and color, that is categorical. Okay, so next, advantages continuation. No need of data normalization. You don't need to scale or normalize data unlike other models, making it quicker to use. Here, scale and normalize the data. In further algorithms, you will get the term. We will discuss in detail about the scale and normalize term in further sessions. Don't worry. Example. Whether a person income in thousand or millions, decision tree doesn't care as long as the data is clean. Even if the even it doesn't care about a income of person. It only need the data should be clean, less affected or no effect from outliers. The data should not be affected by any outliers. The data should be clean. Then only the decision tree works properly. Okay, this is about advantages. Limitations. Small changes in data cause a big change in tree structure, make it less reliable. Means here it is unstable. Small changes, yeah. In the decision tree is a hierarchical format. It will be in the hierarchical format, in a tree based format. If you make a small changes in data also, it will cause big change in tree structure, making it less reliable. Example, if you add new data point, whether it is just a little colder than expected, then it would change the entire structure of the tree. See, even if we add small data or small error occurred in the tree, then the whole structure of tree will be changed, lead to occurrence of improper result. This is about unstable. Poor performance. Poor performance means what? Decision tree may struggle if the relationship between the features are very complex. It may struggle if the relationship between features are very complex. Okay, it assumes that the relationship between variables should be simple and clean. Okay, example, if decision depends on multiple combinations of features, a simple decision tree may not capture the complexity well. Okay, this is about limitations. Applications. Medical diagnosis. A decision tree can be used to help doctors diagnose disease based on symptoms and test results. Yeah, here it uses variables like symptoms and test results to help doctors diagnose disease. Example, a decision tree helping to decide whether a patient has flu based on symptoms like fever, cough, and sore throat. Okay, this is one of the example. Next, loan approval. Bank can use decision tree to decide whether to approve a loan based on few features like credit score, income, and debit. Example, the bank using a decision tree will to decide someone if qualify the mortgage based on their financial history. This is about the applications. Medical diagnosis, loan approval. There are more and more applications are there in decision tree, but I am explaining the basic one. Okay, we will discuss further applications in later videos if possible. Okay, this is about applications. Okay, hope you like my lecture. If you like my lecture, then please like, share and subscribe to my channel Visionary Tech. Thank you for watching the video till end. Okay, please, thank you very much.